Hello everybody and welcome to another episode of No Orientation Programming. I'm Joe and today we will finish our account management, hopefully. I think it will be something between API optimization and introducing the widgets and finishing the authentication concept. So let's see at which point we are. We have the administration process, the administration app, which is able to create a user account, which is able to authorize a user, giving a return value if a user is authorized or not to enter the system. We can restore an account. It has multiple functions. The application has multiple functions, and the game server can communicate with this administration server. Let's call it administration server and game server. So these two are communicating with each other. We have implemented the bare minimum of the processes that are needed for the administration server. And now we need to implement the interface, the user interface for the game server, so a user can input data, user data, and then start the communication between the game server administration server by hitting enter. But for this to work, we need two things. At first, we need to have a concept how the authentication and authorization process looks like, what the user should see or not see, and we need, on the other hand, we need user interface elements that are able to receive information. At this point, we didn't have too much input in our game server. At the moment, we can just start the game server and then connect to it with telnet like this, and then we can hit enter. Yes, that's an input, but there isn't really we have a lot of lists, version history. We can see this version history. We can see the licenses. This is also just displaying stuff. And even if we create a gaming process, then we can only hit one key to decide in which team we want to be. So it's not that much of input logic at the moment. Later on, we will need a lot of input stuff because of the lobbying process, the game lobby, because the lobby will be a lot different than at the moment. It will be way more complex, and so we just need widgets. Wololo. Hi, banana. Yep. Fleißig. I'm totally motivated. Last week I have finished the device states from half assembled to full assembled, and we have a race between the storage stuff, what is in our storage. So I'm happy. Thank you for being at the company tomorrow, and then we will have a chilled beer and then a pizza, like chill working and drinking. And I'm always curious about your state. For me, you have news every week because you're in an interesting process. So I want to be informed. Not really. Yeah. So like, what's up? And you say, oh, no, nothing. Nothing important. I'm just going to start a startup. Coming here before the storm. The storm is heavy. But enjoy the see you tomorrow. Thanks. Bye. Yes, so we will create another directory. This is called widgets, and we have one class that is already in can be categorized as widget. This is the list index class. This class is very useful already, so I'm very happy with this class. It has almost 300 lines, and it is used in a lot of places, like in the creation dialog. This frame will be improved later as well. But the list index class is used here. It's used as a menu logic, and it is used as document logic. So it's quite powerful, although it only has, despite having only under 300 lines of code. So it's I'm quite satisfied. It took a lot of time because it's way more complex than just writing down a process class, because a process class is just going step by step, and this is quite easy. Even if you have a timeout or something like that, it's always the same, so it's easy. This class was quite complex because it contains the business logic of a list element, kind of. And now we want to create another class, a widget class. this is needed at this point because we need some user interface. And I have to make a design decision. Usually I would say we have process data and processes that are changing the data. But I want to make it a little bit simpler. And hopefully this is fine. I had to rewrite the list index class 1 or 2 times. I think I will not manage to make a class and that's it. So I'm just beginning with a class, CPP class, that is called widget. So we have a widget class, that's fine. And I think this should be removed. This is I have to remove this thing sometime. So I want to make some kind of interface class, I think. Yes, that's fine. I have to change the Meson file, the make file, the build description. I have to add the directory widgets. Oh, come on, widgets. Hopefully this is widget. Yeah, okay. Spelling should be right, okay. So I have to add this include, this directory as include directory, and I have to list. This list index is not in main anymore, but in directory widgets. And we want to compile widget cpp. And then we want to have another class that is called cpp class. That's a text box. And the text box is a widget. And we have to compile this text box. Widget and a text box. I hope this is fine. I hope this is fine. Yeah, we will see. We will see. Maybe we have to rewrite the whole thing multiple times until it's as powerful as the list index. I want to reuse the code as much as possible, of course. And I managed to do so with the list index class, but we had, when we made the list index class, we had some requirements, and these requirements, the requirements increased, and this was the reason why we had to rewrite this stuff multiple times. And now it seems to do everything we need. And we will see later what we want from a widget. I think, let's compile this all the time, or does not, yes, of course, width. What? Ah, of course, yes, fine. Okay. Let's see. 45 files already. But it's compiling, that's fine. So now we can start. Okay. Yes. I think a widget has... let's open another class that is very important. Two classes are very important. That is the gamer interacting process. And the authorizing process as is user authorization, a user authorizing process that is account user authorizing. Yes, fine. Ooh, I don't think we need these files. I think we can create another process that is called TGSA requesting, because this will be yes, it should be a JSON processing class. We will need to implement this as well today, hopefully. Processing, JSON processing. Yes, fine. JSON. User authorization account, and this is TGSA requesting, and I think we can remove this one. Yes, I think. Let's see. Okay, fine. So this is just a class, a JSON processing class, which has as input some arguments as JSON elements, and it gives us a result as JSON, and this is what we get from the administration server. So I think it's fine to make an abstraction. And we will need this this class. Okay, that's fine. Then we need Yes. Step by step. Okay. The authorization process. The authorization process. Oh, come on. We already have some logic in this process class, but it will change a lot. Because I think it is clever to encapsulate the SSH authorization process, SSH authenticating, into the user authorization process. Because we don't want to know some in the game injecting process, we only want to know if the user is authorized. If we have, let's see, if we have a secure connection, then let's start the secure connection. But in the last streams we had created, we have created an SSH transferring process, which is encrypting and decrypting the data. Then we have made an SSH authentication authenticating process in the user injecting process. And this is this is the not very useful thing, because we have to change the SSH authenticating process. Oh, yes, fine. The SSH authenticating process is waiting for the authentication service request. Then it is waiting for the authentication request. And if it has, then it shows, okay, access requested, user, service, and method. Then it checks if this was if the method is password. If the method is password, if it's not password, then the response is false. I think the default is false. False means you are not allowed to authenticate with this method because it's not password. The method is not password authentication. But if the authentication method is password, then we return positive immediately. And outside of this process, in the in the gamer interacting process, we check if the authentication process, the SSH authentication process, returned positive. If yes, then the authentication request response is true, successful immediately. And this is fine if you the reason why we did this is because if somebody is connecting to the server, then we wanted to be able to show the login process, but unfortunately I think it's not possible in the SSH protocol to implement it like that, because we can have multiple stages of authentication. We have multiple authentication methods. So a client is trying multiple ways, and we should check this today so we get more information. Unfortunately, it's no rocket science, but it's not easy either. So something in between. We have to check some things and then we can decide. So the first thing we have to test, otherwise the restructuring will the restructuring is depending on this. We have to know how different clients we will test: OpenSSH, SCP and PuTTY. How these clients behave if we propagate multiple authentication methods. And I think these authentication methods are prioritized. I think they are prioritized. You know what I mean. I think the authentication methods have a certain prioritization, and the first one, the first one is none. Yes, that's just, yeah, it's like that. The first try is to use no authentication. And we always have to reject this. So I think responses, behavior of different clients. Put the sending method none as soon as the user has provided a username. Yes, of course. Depending on the response of the gaming server, the client is requesting a password from the user or not. Yes. So we get, the first thing we get is none. Then we have to reject. And then if we, depending on what kind of authentication methods we provide, the next prioritization is public key and then password. I think the clients are first trying to authenticate with the public key of the with the user public key, and then if we get a failure, then a rejection, then I think password is used. And we have to check this first. So we have the next focus on SSH authenticating, and for these three clients we want to describe the behavior. Sending method none immediately. Specific user can be provided. Yes, specific user can be provided. Otherwise, the user of the operating system is used. Depending on the response of the gaming server, the client is requesting a password from the user or not. Okay. So, we make another state again that is as a authentication temp. We remove the timeout. We want to have an authentication service request immediately, regardless of the client. We want to have the request for the authentication service immediately. So we have a timeout. Then we check all the stuff. And then we say authentication service okay. We send the banner. And then we wait for the authentication request. And we do this without any timeout. Why is this? Okay, we have to check. Send. Okay. Sending an authentication service request immediately. What about this? No. It's tick. Yes. Yep, perfect. Authentication service request immediately. Sending an authentication server request immediately. Sending method none immediately. From the user. Depending on the response of the game, the client is requesting a password from the user or not. And I think this is the case. Oh, come on. Let's see. I want to. User timeout. Yes, this is not. Attempts, and then we do not return positive, but we go to another state, and this state is called temporary state. Perfect. We compile this thing, and now we try to log in with SSH. We can see received authentication service request immediately. Sending OpenSSH, sending an authentication service request immediately. This is true. Next, sending method none immediately. Sending authentication request. Sending an authentication request with method none immediately. Sending immediately. This is true. Fine. So we can expect these two to be received in this case immediately. That's fine. Okay. Now let's try clients, and then SCP. I think this is the case. SCP port 4001 of A at B at localhost, and it's not working. Yes, P is port. At the end, port 4001, hopefully. No such directory. No, it's not working at all. Yes, of course. We want to send build native and some text. Send me text to the home directory. Yes, fine. Oh. So we have received an authentication request immediately and received an authentication service request and an authentication request for an SSH connection. What's this? Yes. Okay. So this makes sense. This has a kind of the same behavior, but now we are using putty. We are using SSH and then we open. We connect once. Received authentication service request and then okay, different than I thought. That's different. Sending an authentication service request immediately. Sending an authentication request with method none as soon as the user has provided the username. So this means our timeout for the first stage is valid and it can be even shorter. No, it cannot, because sending an authentication request as soon as the user has optionally accepted the connection to an unknown server host. So this is the reason why we have a user timeout and not for this authentication service request. Okay, that's fine. That's fine. So the user has set up the host key, or the user has to decide within 30 seconds if the user is trusting the host. That's fine for me. Okay. Then, and that's the next step, we can remove this timeout variable because we don't need it. We don't need the timeout at all. We do not set up the state the start variable at this point, and we only send. Oh, that's so bad. Let's see. Let's not make this thing optional. Yes. And we only want to reject as soon as the user has optionally accepted the connection to an unknown server host. Mm-hmm. Sending with none immediately. Yes, that's just an information. Now we are waiting for gaming server. A list of supported authentication methods. So it's waiting. Yeah, not working. Immediately waiting, depending on the response. Waiting for gaming server. List of supported authentication methods. Depending on the response of the gaming server, the client is requesting a password from the user or not. Okay. Sending immediately. Sending immediately. Sending. Waiting for user to accept connection to an unknown server host. And then sending immediate. Waiting for user to input username and to provide username, and then this. Depending on the response of the gaming server, the client is requesting a password from the user or not. Okay, I think this is it. I think that's fine. So we have this special thing here. Reason for user timeout in out service request state. Then we get the authentication service request. Waiting for user to provide username. At this point, we just want to reject the method none if the name of the method is none, then we respond with failure, and we give a list of supported authentication methods. And the list is Fill a name list, and name list is, oh come on, name list. Name list is name list. I think this name list. Yes, a string containing a comma separated list of names. Okay, fine. And what kind of authentication methods are possible? That is password and public key. Responses to authentication requests. If the server rejects the authentication request, it must respond with the following account authentication requests that can continue. The authentications that can continue is a comma-separated name list of authentication method name values that may productively continue the authentication dialog. It is recommended that servers only include those method name values in the name list that are actually useful. However, it is not illegal to include method name values that cannot be used to authenticate the user. Already successfully completed authentications should not be included in the name list unless they should be performed again for some reason. The value of the partial success. Okay, there is no prioritization. So I just can public key, include public key. And I think the clients will choose public key first, independent of the sequence. Okay. Okay, I want to implement this. Should already successfully completed authentications should not be included in the name list. Yes, okay. This class has to make a sense. That means we have to provide a const std string reference method. Yeah, it's strange, but we have to do it like that. Okay, so we have an STD list of STD strings. This is a list of mlist methods left. Methods left pushback is password and public key. And we will remove this. We will erase the respond. We will remove the responses in every case, no matter if we have an OK or not. That means erase. I think it's gonna erase the method, and let's see if this thing even compiles and still compiles. Nope. No matching function call to. Yes, that does make sense. Game interacting. We will not. Oh, come on. Respond. We will delete this line. No matching function call. It's not called erase. Erase is not the... it's called remove. Yes, remove. Removes from all the elements that compare equal to value. Yeah, fine. That's cool. Let's do this. That's fine. And okay. Es ist yeah, authenticating respond. We don't need this string at all, I think. We are removing the methods left, but now at this stage we have to use an iterator that is a list of strings. Ah, come on. Const iterator iter is equal to the beginning of our methods list, begin, and then we say iter not equal to this thing, plus iter, and then that's strange, but fine for me. String methods. Whatever. Blob it. Okay. I think this is it. At first, at least. So if iter is not equal to the first element, then we add this thing, this delimiter. Otherwise we say str methods plus equals to iter. Okay, so we have an authentication request respond, no matter if okay or not. We have a specific method. We remove this method immediately because it went fine, it's okay or it's not okay to use, it's removed. There is only one attempt for using one method at a time. Yes, that's important. We have to remove this immediately here, and then we can respond with a success, and that's fine. The interesting thing is that a client can send another authentication request, although the authentication was successful already. I think, yes, that's possible. But if it's not okay, then we have removed, in any case, we have removed the method, and then we can send a failure, and we have to send the remaining possible methods. Should we use this default constructor? I don't know. Okay. We have these two methods, password and public key. Fine. Yeah, let's check this. Now, I'm very curious what is happening now. My guess is, let's see what. Wait a minute. We are waiting for an authentication request all the time. Received authentication request. If the method is none, then we respond automatically with false. If we have to break here. That's fine. Oh, yes. Yes, that's it. We have to break here. We don't need the temp. We just break here, that's fine, and we can, yes, leave it at is it. Okay, let's check. Received authentication request, none. Authentication receive wait. We are prompted with a password. First none and then password. I didn't expect this behavior. Let's see if it's different when we use this, and then I want to make a process warning log suggesting these methods. Oh no, this is wrong. Come on. Proc warning log. Suggesting public key and password. That's strange. Let's see what this thing is. Authentication lookup. Okay. Authentications that can continue. Public key and password. Start over. Past a service accept. Service accept received. Send packet type 50. That's an authentication request. Received packet type 53. That's the input banner. Received packet type 51. Authenticated using none with partial process. But a failure. I think it's a failure. It must be. False. None is false. Authentications that can continue. Public key and password. Start over. Past a different list. Public key password. Preferred GSS API with MIC. Public key, keyboard interactive and password. I think. Okay. Preferred public key and then password. I think this is a prioritized list. Authentication method lookup public key remaining preferred. Okay, so it's going through all. This is the preferred list, and it's going through this list from left to right. And as soon as one of these methods is found in this list, the gaming server has sent, then this is used, and this is the remaining preferred. Authentication method is enabled public key, yes. Next authentication method is public key, as expected. So I expected this prioritization, public key over password. Offering public key, yes. Send public key test, no. No mutual signature algorithm. Okay. Okay. I understand. One moment, please. So that's a long hard road. We have installed an RSA key, and the client knows from the server has sent in the key exchanging process during the connection establishment. The server has sent a list of supported signing algorithms. No mutual signature algorithm. We told the client that we only support elliptic curve DSA. And to be able to test the behavior of the client, we will not support public key authentication at first, only the password authentication, but we have to know how the clients behave. So we have to change a certain list. The list of supported yes, that's the list. Here we have the lists, and these are the lists of the algorithms that are supported, and that is public and no mutual signature algorithm. Let's see. In the, I think it's this, the transport layer, yes. Signature public key algorithms. This protocol has been designed to operate with almost any public key format, encoding and algorithm signature and or encryption. Signature and or encryption algorithm, encoding of signatures. Okay. Here's the list. This is the algorithm negotiation. The key exchange begins by each side sending the following packet: key exchange init, cookie key exchange algorithms, server host key algorithms, encryption, message authentication algorithms. Each of the algorithms name lists must be a comma separated list of algorithm names. See naming in and additional information numbers. Each supported allowed algorithm must be listed in order of preference from most to least. The first algorithm in each name list must be the preference. Each name list must contain at least one algorithm name. Cookie. And these are the algorithms. So this is it. If no satisfying all these conditions can be found, the connection fails and both sides must disconnect. Server host key algorithm. A name list of the algorithm supported for the server host key. The server lists the algorithms for which it has host keys. The client lists the algorithms that it is willing to accept. Actually, I don't know. Let's see at which point. No mutual algorithm. SSH connect to no mutual algorithm, a key signing algorithm. Keys for public key signatures. Color must be call with to ignore server sig extension list and only attempt with the key space signature type. I think it's just this list. The server signature list, I think. And what the hell? Yes, okay, fine. So yes. Nope. I think this is it. The list, yes, perfect. Of protocol extension user authentication methods. What does that mean? No. Host key formats. Yes, that's it. Oh, I think we have to use this. Yes, I think. Let's see. Let's try this again. RSA. Okay, this is different. No. I think this is the same as here. Next authentication public key, offering public key, this one. fine. But send public no mutual signature algorithm, yes, and the same we have here. Okay, let's start Wireshark. Loop back, and then as port is the TCP dot port is this. The key exchange init of the server should contain the algorithms. This one, this is fine. So the change is fine. Encryption, key exchange. Why? The signature algorithm will only differ from the key algorithm. At which point key type allowed? Option allowed. Find the first entry in public accepted algorithms. Do I have to add this somewhere else? Who do? That's bad. That's bad. Okay. That's bad. On null if no mutual algorithm found. Okay. Call to ignore. If SSH is null or key exchange server SIG algorithms is null. Let's see. Fallback SIG type. How is this defined? Mhm. That's interesting. That's a number between 0 and 1. If it is 0, then we have null. If it is null, then match list SSH key name options public key accepted algorithms. What? Hmm. This is a for loop. And the first thing it tries to do is 0 and then 1. If this function fails with 0, then what is it doing? It is aborting the for loop. It's aborting the for loop immediately. So we don't have a second iteration to fallback sig type 1. That would provide another. Here RSA bug sig type. Do we have to advertise this thing? Oh, come on, no, please not. Okay. Which one? Let's see. This, what's with this? No. Not found. This is the protocol architecture, not found. This is some extension. Oh, come on, I have to advertise. Why is failing for this user? Extension negotiation for the secure shell. Oh, come on. Please. Received packet type 7. and servers to exchange information about supported protocol extension confidentially after SSH key exchange. Oh, come on. Value 7. A party that received the X info C or X info indicator may received the extension info indicator may send the following message. So why don't SSH2? Haha, okay. Message. Yes. Okay. Okay, the define is different. So this is an extension info, that's fine. And in this case, the user has received the packet type 7 received expecting new keys. New keys means the Okay. I'm fine with that because then I don't have to advertise another server host algorithm. We only have to send a packet. We have to store the RFC as PDF. Move downloads RFC. Okay, fine for me. Server signature algorithms. Hi, can you explain what the problem is? What I got so far, you are trying to authenticate an incoming connection, right? Yes, the problem is the following. We have we have two applications. The game server, it's working fine, and it has to authenticate the user. We are asking a second application that is called the administration server if this user is permitted to connect to the server. And at the moment we want to implement the user interface on the gaming server side, which is doing all the processing for the authentication. It's asking the user how do you want to authenticate. I have to authorize you, the user, on the administration server, and we are telling the user you can authenticate with these two methods, public key and password. But I thought that, like in this RFC authentication protocol we have, if the first step of the user is the user tries to authenticate with no method, then we reject this attempt, this authentication attempt. The first authentication attempt of the user is none. We reject this every time, and then we suggest two methods. But and this is in RFC 4252. We send an user authentication success, or we send a failure. One moment, yes. Responses to authentication requests. If the server rejects the authentication, as in the none case, it must respond with the following: SSH message user authentication failure. You can't authenticate with method none. You have to give us something. And then we send a authentication methods list, a comma separated, and this can have one of these, can be one of these, public key and password. And I thought that this is enough to send this list. We have sent this list, but the client tells us it has received the list, public key and password. Yes, we said you can't authenticate with none, but with these two. And now the client is trying, checking its priority list. This one we don't support, this one we support, then this one, and this is the least significant, the lowest priority. This is the next priority, public key. It's found in our suggested list. And the client is trying to use this method, public key. And it's searching on the client host on my computer. It's looking for installed public keys. The next authentication used is public key, and it sees that we have an RSA ID. We are trying to use this, but this particular file, this identification file, is not used because we have to provide in a completely different message. In a completely different message, we have to provide to the client the information that it's not part of this RFC. We have to provide a special message, an extension message, to tell the client that for the public keys we support certain algorithms, and we did not send this message. And this message is defined in RFC 83, and that is initially defined extension server signature algorithms. This extension is sent with the following extension name and value: string, sigalgs, and public key algorithms accepted. So it's a different message. We have to write a function now. Cool. That's cool if you got it. Thank you for the response. It was a long explanation, but we are very deep in the rabbit hole. We have left the API administration server rabbit hole, and now we are going into the next rabbit hole. The reason why I really want to see this is because we have to be compatible with multiple clients. I want to connect to the gaming server with OpenSSH, SCP, and PuTTY for Windows and Linux, so multiple clients, and I want to see the various scenarios, the various situations we can have, or cases we can have for different clients and different authentication methods. I want to see how it is working, because the user interface is depending on the behavior of the clients. So I expect that if I send these two methods, then the first public key has a higher priority. It doesn't make sense to have a lower priority, because I want to install the public key so I don't have to input the password anymore. So, and this is what we can see here in the log of the client. It has this priority list, and public key is higher, has a higher priority than password. So, but the cool thing is that in this log from this user, I can see at which point the client gets this special extension message. So we just have to create message extension info, and this has the value 7. That's fine. Our server has to create this. As you can see, server signature algorithms. This is the same. We have to send this packet. It's not that special. And that's the cool thing. Here we can see it's sent between the new keys message. The server, the client has sent a new keys message. That means the negotiated keys are used by the client at this point and used by the server at this point. Both sides are negotiating encryption keys, and as soon as this process is done, both sides send the new keys message. That means now for the next message I will use the new keys. This is the last message you get with the old keys, or the last unencrypted message that you can see in the Wireshark. For example, the client is sending a new keys message here. And then the server sends its new keys message. So they're negotiating the keys and then they use it. And we can see this is after, at this point the encryption has started. Every packet after this point is encrypted. Rekeying after this amount of blocks. And then send packet type 5. The client is sending a packet type 5 that is a service request, as we can see here. Yes, that's fine. So I'm at the moment I'm locating where I have to input the code, and I think it's at the beginning of the SSH authentication process. We have an SSH transferring process. And the transferring process is given to the SSH authentication process. Okay, fine. We try to make a different approach. We try to make a different approach, and let's see if this is working, hopefully. In this log, we see that the client is sending packet type 5, that is the service request for authentication. And in this log, we see after the client has sent the request, the server immediately sends, hey, if it didn't accept the server didn't accept the service request by now, but before that the server is sending, hey, you know, extension info, special info for you. If we have later some public key authentication, maybe, then this is the allowed algorithm list. And we make a different approach. We wait. Okay. No, we make the same approach. Yes, we wait for an authentication request, and as soon as we have received an authentication service request, then we not only send an authentication service, okay, but we also send something else, and that is public pub key info send. Let's call it like this. I don't know. And we send this. So we send, if we receive an authentication service request, we are waiting for the client we are waiting for a request from the client, and then we are very verbose. We are talking a lot. We are sending, hey, hello client, we have an info for you, and yes, this authentication service is okay for you. And then we immediately send, we send 3 packets. We send the banner, 3 messages immediately. And this message is created like this. We have an extension info for the client. What kind of info? We have the info that we support some server signature algorithms, and then we tell the user a name list, public key algorithms accepted, and that is at least this one. Only as few as possible. And this connection is encrypting the packet already, so this should be fine. And let's try if this is working. Now we should see the same a log info like that. So this is type 5. Type 6, type 5 is the authentication service request. Type 6 received packet is the service accept. And type 7 is an extension. This did not work. Let's see. But at least public key received packet type 7 SSH2 message extension info received. String is too large. What the hell? So the client disconnected because I've not read the message, the blob add. Let's see. We have a length. The message info is fine. And then we have two things, I think. The reserved size is... that's a good... Oh, thank you. Very likely. That's a very good. Thank you a lot. That's... It was a good try at least, because this is kind of very... It was very small, yes. But I think I've not read this document perfectly when acting as a server. Yes, that's the problem. We have to insert this, I think. I did not... Yes, see, this is the base structure. This is the base structure of this thing. I've just tried. This was a trial and error situation. I did not read anything. So we have to number extension. So this is the base structure of an extension message. That means we just have the wrong format, and this is fine, but here we have to include a number. That is, we have an info for one extension. Repeat the following two fields, number extension times one extension. Then we have the extension name and the value as a string. So we have I have missed this this integer. This was trial and error. Yes, I think that's better. That's perfect. That's perfect. Yes, it's one step better. This is why I never trust forum posting so much. So, yes, this information was not. This information is fine. This is just a log from a random user, and we see that this user is very likely using an official SSH client and an official SSH server, but we are making our own server. That means we just have to make the correct packets. It was my fault. I was not reading it. So The forum post itself is fine. This user has a completely different problem. But okay, so now we should see, yes, a different, oh, that's perfect. That's so, that the log is now different. Authentication, we have sent this list, public key, from server to client. These are the supported methods, authentication methods. The client is trying, these are the preferred methods from the client, and it's trying public key first. Then it's looking on the file system, what kind of IDs, public keys do I have? And we see we have this one, and this one is supported by this extension info the client has received. Server signature algorithm supported this one, and because this one is now in the list of the client, and the client is checking, I have this file. Did the server tell me it is supported? Yes. And because of that, it has sent, and this was the intention, it has sent an authentication, not authentication, service request. This is done already. The service request has been accepted by the server, but now it has sent, the client has sent a packet type 50, and that is an authentication request with a certain method. And this is the public key method. And because I was lazy, and in the high level process I always try to keep the buffers as small as possible, and the transfer layer has very small buffers, very small buffers, 5 bytes or something like that, and 16 for the encryption buffer. But the high level processes, I accept a bigger buffer, but this buffer has only 64 bytes as well. So for testing, I will make this buffer a little bit bigger. Making it, oh come on, 2048. Because I just want to see the process itself. And as you can see, we have chosen a big enough buffer, so we do not end the connection. And this is exactly what we want to have. This is fine. We have sent, we have the client has sent an access request, an authentication request with method none. We rejected. We sent to the client this list as seen here. And then, as expected, but I wanted to be sure because this is important, as expected, the client is first trying to use the public key because it is overruling the password method. Now I want to test something else. I want to switch these entries, and then I guess the client is still sending public key first. Let's see. Now we have sent password and public key, and still the client is sending public key as expected. So the client is working as follows. The client is receiving a list of supported methods from the server, and then the client is going through its own prioritization list, and it's going first element, is this element supported? No, it is not supported. And then public key, is this supported? And it doesn't matter if this is at first or at second. Is it containing is it in the list from the server, the supported list? Then yes. Then this is the next try, and the remaining are these methods. And I will try public key. I have this ID, sending this file. And now we can in the future implement. So the received data length is 345. We can decrease the buffer size now by 512. It should be working still. That's cool. Yes. Now, because we are not implementing this authentication method at this moment, I just want to test the behavior of the client. Yes. Okay. So to test this, we tell the client that we support these two methods, but we fake it. We say we support it, but as soon as the client tries to authenticate with the public key, then we just decline it anyway. So we say if the name of the method is public key, then we return this one, and we have to remove the entry from our supported list. Now we should have the step. The client is trying to authenticate with the public key because the server sent a list that it is supported. And then the client is trying to use the public key. The server is rejecting the public key in any case because it is not implemented yet, and then the server should return failure and the remaining list. This means the server should only send a list of supported authentication methods that are that may productively continue the authentication dialog. That means we have to remove the first this method because the attempt has failed, and then we only send password, and then the client should request the password from the user. So let's see, and as you can see, fine. We have received the method none. We are suggesting public key and password. Because we are suggesting these two, the client tries to authenticate with public key. We have sent no, this failed. Let's see. Send packet type 50, we send a public key packet, wait for reply. Received packet type 51, this is the response. Authenticated. This is a bad chosen sentence because it's authenticated using public key with partial success. Partial success means failure, but we have understood the request. So the protocol means we respond with success, or we respond with no success, but partial success. That means we have at least understood the attempt. So we have returned failure with partial success. and then authentications that can continue. And as you can see now, we have removed the public key entry. The server is telling the client, nah, now the last thing we can do is password. And then the client again is checking the remaining list. Okay, password is in the list. And we are trying to use password, and then as you can see, the client application is requesting the password from the user. And if we enter the password, passwordos, yes, we don't see in the log that the actual password, but you can see that we are suggesting a password, and yes, you can, here we can see the passwordos. This password I've typed in passwordos, and this is the second attempt. Perfect. Perfect, because now we have finished the optimized and we have made the last changes for the SSH authentication request almost, because we make another function that is called no, it's not unencrypted. Everything is encrypted. I can show you. I have Wireshark. I refresh the Wireshark log, and then I try to connect, and then the password is cat. In our log, we can see the clear text because I have activated the clear text in the log. This is because in Wireshark I don't have the communication is encrypted already, so I have to print the password here, and all the communication I have to check the communication in the log, because as you can see, only the first packets are readable. That is the client protocol, the server protocol. Then the key exchange in it is just a list of supported stuff from the client and then from the server. They are just telling each other what kind of algorithms they know. And then the hot part are these two messages. The client is sending a big number, an cryptographic relevant big number. That's an integer, a big integer it's called. In the RFCs, the SSH RFCs, it's called MP-int, multi-precision integer, and that's the format, just a bunch of hexadecimal numbers. The client is sending this number, and then the server is responding with a bunch of other numbers. It's out the server at this point. The server, this is the transport layer of the SSH protocol, and at this point the server is authenticating itself by its host name, host key, and it's sending another public number, and it is sending the new keys info that these that the keys, the encryption keys, are now active from the server point of view. And then the client is sending the same message that the encryption keys are active from the client view as well. So they have activated the encryption keys, and from this point on, the whole packet is encrypted. And at this point, the next layer has started, and this is the authentication layer of the SSH protocol. And as you can see, the client is sending an encrypted packet, then the client, then the server, the client, server, and at some point you have the password, but it's not readable, so it's encrypted. So you see this encrypted packets, but you can technically, if you have the internal private keys, the server and the client, each of them is sending a number, and this number has two parts, a public part and a private part, and the public part can be sent over the channel, and the private part of this number is a secret for both peers, so they are not allowed to send this over the network. But because we are implementing the server, we have these secrets. We can print these secrets in our log, and we can set these secrets in theoretically in the protocols from Wireshark protocols. Then you have to go to SSH if you find it. My problem is I don't know the alphabet. I always have to scroll multiple times because I don't know the alphabet. SS, yes, SSH. And then you can add a file that is called the keylog file name. And the keylog file name, this file is containing all the private information that is which is a secret. You should not make your server in the production environment. The server should not create this information anywhere because it's revealing information for the encryption. So this is private. But if you have set this thing, theoretically, you are able to decrypt this communication with Wireshark if you have the secrets. If you have the beginning of the communication in the Wireshark log, and if this key file is supported, but at the moment the type of key is not supported at the moment. If I use a different key mechanism, then this is then you can decrypt this with the private keys, but it's not implemented for elliptic curve key exchange. So it doesn't matter. We see that this communication is encrypted in the Wireshark. That's fine because we are reading everything in our own log. I will remove this log, of course, after I have finished all the stuff. After I have finished the implementation, then I will remove this log output because you don't want to see any password in the logs, of course. So this is just for debugging at the moment. This will be deactivated completely later. Yes, absolutely. Otherwise you have a problem making everything secure. If you make everything secure and then you store the passwords in clear text in a log, then this is a beginner bug. So you should not do this. And as soon as we have received a password, we are discarding the password immediately in the system. We are calculating the SHA 256 immediately, and then this is the new representation of the password in the system, because we don't want to have the password in the RAM or something else. The first thing we want to do is to make a hash out of the password, and with a prefix. If the user has a weak password, we append a prefix. This prefix should be unknown. We append this prefix, and then you should not be able to rehash the password, because if you have a rainbow table attack, if you have the hash and you use a rainbow table, for example, you have the password cat, then it's very likely that the hash of the password cat is in a rainbow table, and then if you look up in the rainbow table, you see the user password is cat. But if you use a very long prefix for this hash that should be secret, then if somebody has the hash, even for a weak password, it should not be able to regain the password. Hopefully. Okay, so we make a helper function that is called password. Let's see. Let's make a success. Password parse. Method password. Oh, come on. Sometimes I can't decide. We pass this message. That is from the buffer. We fetch from the buffer, we fetch something. We try to fetch could not fetch password bool. That's in character. Yes, fine. The password bool should be 0. This is we can read this here. In the authentication layer, SSH has 3 layers. The transportation layer. This transportation layer does 2 things. The first thing is the server authentication. The server is telling the client its identity, and the encryption, of course. And then we have 3 layers again. And the second layer is the authentication layer. In this authentication layer, the client is authenticating to the server. And then the third layer is the data channel layer. And in the authentication layer, we have multiple authentication methods, and the password method has is a packet that looks like this. That's a user authentication request. This is a byte. Then we have a string username. Then we have a service name like this. The service is an SSH connection. The user is requesting an SSH connection. and the string must be password, method password, and then we have a boolean, and this boolean must be false, password, and then false. And then the plaintext password in as string, and a string we have 3. This is a string. A string is stored in this protocol. A string is not stored as a zero terminated string like in C, but it's stored as length, unsigned integer 32 value representing the length of the string, and then we have the length of the string, in this case cat. And of course, if we have received, if the method name is password, then we have to pass success is equal to, no, let's make it like this, break. I'm always using ifs in a negative way as much as possible. So I have an exception case here, none. Then I have an exception case here. And then I have another exception case. Theoretically, we should return Yeah, no, let's keep it simple. Let's keep it simple. We could return. Yes, this would be an unknown. Yes. If yes, perfectly, absolutely. Ah, that's cool. We can, yes. We have none. Then we have public key. Yes, that's fine. That's fine. Theoretically, if we are very, very how should I say? Theoretically, the client can send 2 public key requests, and then we are responding with the same message. We could check if the method is in our supported list like this. If name method is in supported list, but I don't want to make a function. I will make it like you said if it is not none, if it is sending multiple public key requests, then we say, okay, we are always responding with false. You can just use password. We could be more strict that we only support 1 public key attempt. Okay. Yes, fine. We could also say Let's make it like this. Then 4, I don't know. So we can, that's a very cheap version of, come on. The out attempt number authentication. Is it with 2T? Attempt. Yes, fine. Max. So we don't have a magic number. Define. That's 4. We have a max attempts, and then we can increase this too. So we have the first attempt and the second attempt, and maybe there is another attempt with the same response. If it is not none, if it is not public key, and if it is not password, then as you have written, unknown authentication method, and I always try to give some information in the log, because I want, if everything is fine, the policy is like that. If everything is fine, I don't want to see anything in the logs. The log should be very quiet, but if there is an error, then I want to get useful information. And in this case, unknown authentication method, then I'm asking what did the client send, and then I want to see the authentication method the client has sent. If it is password, then I want to parse the result, and if the success is not equal to positive, then could not parse password authentication packet. So we try to get the bool, the password bool. This must be 0. So the buffer has to contain enough data to fetch a bool, and then we try to check if the bool is 0. And then we try to fetch a string. Oh, what did I do? What? Okay. That's the last stuff we have to copy, and then we can remove the break. If this is not positive, the process is not ended at this point. We are not return positive here, because the authentication process should be pending forever. Not forever, but the higher process is deciding if the authentication is done. So that's fine. User ID and user password. So this is set, and we want to create the result is not a user ID and not a user password. The result should be a pipe of JSON JSON values. So we have a queue. This is a queue of JSON values, and the SSH authentication process is filling this queue. So the SSH authentication process is running in the process tree. It has been started. Let's see if we can compile this. Can we compile this? Hopefully. Come on. Yes, I have to success. One moment. What? Buffer. Shouldn't the password parameter be a part of a class? I think this is, thank you, I think this is the problem, yeah. Ah, you're good, you're amazing at Technomonk, nice. I have forgot, of course, that this function belongs to the class. Was not declared name user, yes, because I have name user, yes, this is a variable. Ooh. Name service is fine, name method is fine, but name user received authentication request. Okay, let's change this to a std string m name user. We remove this. We change m name user. This is a member variable now. Maybe uninitialized, come on. P-buffer, yes, p-buffer is equal to something. And here we have, yes, buffer fetch. That's true. Yes, that's very important. That's very important. Our function needs to have the start and end point of the buffer. So we need this thing, then we can remove this thing, and we have started the parsing process, and then we continue the parsing process. Invalid conversion to const, yes, that's true. Because that's a completely different function. Of course. We don't need this theoretically. Then let's remove it. And as this is our process tree of our application. These are all the this tree is showing all the processes that are running, and I have these processes are invisible at the moment because in the message dispatching interacting we are creating this thing, and then the peak, that's the gamer. No, we should see it. Yes, we see it. I have to connect, of course. This is the process tree of the application. We can have multiple processes running in parallel, and it does not matter if they are in different threads or not. But this is the root process, game supervising. This is containing the debugging process and the application process itself. Then we have the gamer interacting. The connection is secure. The gamer interacting process has started an SSH transferring process, and which is using a TCP transferring process. And as you can see, the SSH authenticating process is still pending. It's in the state authentication receive wait. At the moment, this process is a child of the gamer interacting process, but we will change this later because the gamer interacting process is starting. Will be starting later immediately the user authorizing process, and this process is starting the SSH authentication. And this is only a service process that is trying to receive an authentication request, and for convenience the output should be gamer interacting. We don't want to have this has to be removed, and we don't have we remove the user ID and the user password, so we remove this so it can compile. If we remove these two, so we are not storing these two information in member variables but in a JSON value. So we are using JSON, and this is an authentication attempt, and authentication attempt ID is name user is equal to name user, and in this case pass user is equal to this one. ID user, and we have a type that is password. Oh yes, this is the password. And very important, Mm-hmm. Perfect. Let's try to compile this thing. Ah, come on. Oh, yes. Ah. We have to use a secure byte block. I think. No match for operator. Yes, of course. Boah. Holy moly. Some typing issues. We have a string, and this string can be created by a point in the length, I guess. String zero constructor. I think it's a char point and a size, yes. That is these two. And then I have the string, and for the string I have this function. Name user, fine. Then I try to create a password user, that's a secure byte block. Then I make a string. Not the best thing, but it's fine for me. Basic string. Unsigned char. Const char pointer. Data. Not data. How about const? Is this fine? I don't know. Let's see. At least it's not crashing. Crypto ++ samples. Oh, it's almost at the end of the stream. Oh, come on. Secure byte block. And we want to. Const pointer. Const byte pointer. I think this, maybe we can just use a byte pointer. Byte pointer, yes, but that's an unsigned char. Data pointer, const data pointer. And I guess the not the gaming function, but this is only, no. Hey, we have a string function. We can remove this. Yes, that's fine. and data, and yes, this should be fine. This should be compiling. When the JSON really out and goes out of scope, is it stored saved somewhere? I have never used JSON, by the way. No, we are missing something. I wanted to compile this thing first, but you are right, because we have to. This is the interface of the SSH authenticating process. We are starting this process because we want to have a certain function. The output from SSH authentication is our pipe, our queue, which has the type JSON values. This is attempt, and so the pipe attempt, and then this is the response for this. We are always trying to fetch something from the queue, some attempt, and these attempts have a type. We simplify this protocol. So this protocol is making all the parsing stuff for us, and then we have to insert this attempt, and I think it's called commit. I'm forgetting my own, so it's this is copying. This is copying, and let's see. Yes, user ID. We don't have a user ID anymore. That's fine. Ambiguous overload operator. Yes, why? Because this is strange. This message is strange. We have the password. What is the password? We are fetching the password as a secure byte block. Yes. I see. Oh. I see. So I think we have two functions. The first one is returning a string, and the input is a string, and then we have a second version returning a secure byte block and expecting a secure byte block. And now, of course, we are trying to get a password in a secure byte block. We need a similar function. That is something in between. I will refactor that later. Another function that is accepting a secure byte block and returning a string. String digest. Prefix update, plural data. Update. I don't see any difference, so we have I will merge this function later. Okay. I understand. We can't do that either, because the secure byte block can be converted to a string, I guess. So fine, then we need to have this is the password. Pass user. That's the string. The password user is from a clear text value in a secure byte block converted to a hash value still in a byte block, and then we have this thing, so it's fine for me. We have to make a const char pointer cast as before. Okay, that's fine for me. Test. That's fine, that's the hash of our password. When the JSON value out attempt goes out of scope, it is stored safe somewhere. Yes, now it is stored in the pipe. So the process is running all the time. It's communicating over the SSH protocol, and we don't care about the SSH protocol. We just want to use this process to receive some authentication attempts, and we don't want to know anything about SSH. We just want to have a JSON file, a JSON structure that is telling us there is an ID, a type, what a kind of attempt, a password attempt, the ID of the user, and the password of the user. So fine, and that's cool. That's cool because now we really have finished this process. This process is done. It's communicating fine, it's waiting, it's receiving whatever attempt it is needed. Theoretically, if we support public key, then we replace this response false with another parsing function, and then we can put a different attempt into our JSON pipe, telling the parent process we have another attempt that is public key, and the ID is the name of the user, and the public key is something else. But at the moment we are just ignoring this. That's fine. So this process is done, and we have proven that the first attempt is a public key. That was very important. And now another important thing is, how about other clients? For example, SCP. Here we have the same thing. We add a verbosity, and this is kind of the same implementation. We have the same stuff. In the end, we have a password authentication request attempt, and first we have none, then we have method public key, and then the third one is password. So this is suggesting I want to remove this log file, log entry, because it's annoying. What is happening? What was we had an incorrect signature. Interesting. I think I know what is going on, but I thought we have these issues cleared. Invalid sig. Fine. But at least it's working sometimes. The first method is none, the second method is public key, and then we have the third is password. So it's working the same for the clients OpenSSH and SCP, and now we want to check what putty is doing. Putty cd downloads change directory wine putty, and then I hope we are finally done. Checking the behavior of the different clients and the combination different clients and different authentication methods. It's the whole user authentication stuff is a very, very tedious work. It's a lot of work, but we are in the finishing phase. No attempt at the moment. Connect once we have an authentication service request, and it is, yes, we have a method none, that's fine, but putty is not using public key. Maybe because we have to, this is a completely different host keys. We have to load the, that's very strange, a very strange GUI. We have to load the settings and then we can check. The host keys, manually configure host keys for this connection. These are the host keys, but I want to set my own keys, authentication. Here. Private key file for authentication. Let's see if this is working. How can I? I want to set the private key for I want to set the private key, come on. And the dialog is not giving me access to the hidden directory. Ah, come on, this is so bad. Okay. Temp. I will create a temporary public key that is RSA keygen, I think. SSH keygen key generator, and then help, let's see. I don't want to override. I don't care. Enter file in which to save the key. Home, show, temp, and then ID RSA. And the passphrase, I don't want to have a passphrase at the moment, and now I have a key pair, and I should be able to select this key pair in select private key file. I want to select this private key file here. Allow attempted changes to attempt keyboard interactive, attempt authenticate using page. Fine, okay. And now I want to save this configuration, and I open. I connect once. Ah, that's cool. Now I have received an authentication service request, unable to use key file. What the hell is this? The key must be converted by the put again tool. Oh, come on. No. Put the key generator. Oh no. Type of key to generate. Put the key generator. Put again. Come on, download. Not install. The Windows. PSCP, we can download this thing as well. Fine. Put detail, put again, yes, put again, fine. Come on. Let's see. Wine. Potigen. Oh yes, fine. Key. RSA key. Generate key pair. Please generate some randomness by moving the mouse over the blank area. Cool. Please wait. Fingerprint, key, password, confirm, generate a public key pair, generate, load an existing private, save the generated, save in temp. Fine. Temp, this is the public key, id rsa.public. Save the, are you sure you want to save this key without the password? Yes, of course. id rsa, type of key to generate, number of bits in a generated key. I guess this is fine. And now, read access denied for device. Aha, maybe this was the... I think this was the error. There was no read access. Unable to open file. So this is just a temporary file, so it doesn't matter if we see the private lines, but okay, let's we have two PPK, public lines and private lines. This is a container for both. That's the public key. I think I don't need this public thing. And we can just load the settings, going to SSH, and then PPK, then going back and then saving the configuration again, and then connect once. Oh yes, that's fine. Come on, do it. We have an authentication request, then authentication service request, then we input the yes. This thing is trying to authenticate with at first none, then public key, and now we have returned failure. And the third attempt from this application is like the OpenSSH client. We try to input the password and then we can send success if the user authorization process, the parent process of SSH authenticating is deciding to let the user into the system. So this was way longer than I thought, but it is done. We have a pipe. This pipe gets filled with attempts. At the moment only password, that's fine. But this was a special packet that was bad, so I think the restructuring of the gamer interacting process, that is the authentication starting is done, is moved, will be moved from the gamer interacting process to yes, we can do this. This is the last thing. Yes, we have some strange connection going on because the channel ready. We are accepting an SSH filtering, but this is a bad thing. We have to accept something else that is a low-level transferring process. Yeah, pcon, come on. Yes, that's a restructuring now. Pointer mpcon. We have to remove so much stuff. Okay, mpcon is pcon. We do not need a filtering anymore. That is this. Filtering, removing. Authenticating has SSH transferring included. That means we don't need this here. Fine. We just have a transferring process connection, and we are removing all the filter stuff. We don't have a channel ready wait. But we have a state that is called authentication attempt. Wait. We are waiting for an authentication attempt. We cannot wait for a channel to be open. Message authorized. Oh, come on. This is... We don't have a message authorized. And we don't have a message task line. This is kind of bad. We don't have an visualization. Yep. And we don't have we can remove this for a moment. We don't have that's the UAV state, that's the visualization state. Oh, come on. We remove this states completely and we say uint kind of making this process from scratch, but that's fine. Because we have a lot of templates and it's quite fast making this. No. Data setting, I think this is it. Yes. Oh, come on. This is fine. User authorizing state. I don't need this, I don't need this, I don't need this. Okay, I just have a connection. No, that's fine. User ID aborted, username, authentication and connection. I don't have a filter and stuff. I only have a state variable. The state variable is called ststart. I think. Yes. ststart. That's fine. And this is the state variable. This is the process. So, I don't have this. These things. Oh, come on, I will just user ID. Username, user ID. Nope. Nope, that's fine, that's fine. Process, visualize, remove, visualize completely. Key process, completely removing. Authorize. This is interesting. This will be the process itself. State. ststart. I think this was a bad ID. Authorize. I don't need authorize. I don't need visualize and stuff. I just have the this thing. ststart and st authentication attempt wait. Fine. State is equal to this thing. It's just kind of boring work we have to do. Now this seems to be interesting. I think we are almost finished removing all the stuff. We don't have an input and the output is a username and an authentication ring. Do we have an input? No, we don't have any input. The input is the connection. The output is if it has been aborted. Okay, I think this is the output. Oh, that's interesting. So now we have the game interacting process, and that is we don't have an SSH authentication, but secure connection start, and then GI we start the transferring process. Yes. We can move this to here. Yeah, that's fine. I think that's fine. Okay, that's cool. Because the SSH authentication process is moved to this class. State connection, yes. Ah, null. We need something else here, that is generate this state. SSH, now we don't need to wait for the SSH authenticating process to be done. We start our process, the SSH authentication process, yes, fine, and then we wait for an authentication attempt, and that is if now we say success is equal to MP SSH authentication success. If success not equal to pending, return success. Otherwise, we check MP SSH authentication. The attempts pipe. Let's see, we have this is fine, this is fine. We don't need this anymore, widgets. It's not the topic for today, seems to be. Message dispatching PP, and we want to have an success variable success, and we want to have a pipe entry value. We want to have this namespace JSON value. This is entry attempt if not get this, then break, otherwise we have entry attempt, otherwise we have a value attempt, authentication attempt, and this is equal to fine, and then we can check. We can just print the stuff. Proc warning log. So we are moving the information one level higher. Access requested. String name user std string. We have a name of the service, and then we have a name of the method. Should we? Yes. Type. We switch from type to method. We should not use different names for everything. We have to initialize this stuff. Well, we should at least. Oh, come on. What, why we so, no. Name service, yes. Whatever. If authentication attempt dot if not is member method return proc error log -1. Missing field. Method. If not is member. What what type of server management is used for MMOs? Massive multiplayer O's. I don't know. What type of server management is used? Server management. I thought you do you mean user management or server management? Pass user. So we should have all these elements, and then we say name user is equal to authentication attempt method No, that's completely wrong. If name method is equal to this thing, server system for that many requests and securities issues also. What type of server system for that many requests and security issues also? Actually, I don't have any clue. If not, is not equal to. Oh, I have to be careful. Password. I've never seen an internal implementation authentication method not supported. I've never seen an implementation for an MMO system. It's completely different than this thing, because this we have a small server, and at the moment nobody is playing on that server. If you have a big company with a lot of users, then there must be some kind of load balancer system. So if you're connecting to a server, then if you're connecting to a domain, then there are multiple hosts accepting the connection. So you have the load balancer, and then you get redirected, I think. You ever worked with FPGAs? Yes. How do you know that? Mr. Elfman. Mr. Elfman, that's a cool name. That's a cool name. Mr. Elfman. Yes, I have worked with FPGAs. It's quite cool. And I had an VHDL. You ever made a CPU? Yes. You ever made a CPU? No, I did not made a CPU. Yes, I made a CPU, but I have used the CPU. I have created a CPU for our class long time ago. This was a lecture, and this was just a minimal version of a CPU. But then I have used a big CPU, a useful CPU from OpenCores. It was called SCAS, a SCAS processor. FPGA is just pain. Actually, I like FPGAs quite a lot, and I had a very cool. Yeah, okay, yes. Synthesis takes forever. Yes. That's that's true. For my bachelor thesis, I have used this CPU, and the synthesis time was only 20. No, I think 15 minutes. I have collaborated for another project, and for this project the synthesis time was about 30 minutes or 45. So it was annoying already, but this isn't even a long synthesis time for an FPGA project, because the synthesis can take hours. It's completely crazy. So yes, that's annoying. That's actually not necessary, because if the timing, it depends. Yes, it depends. You have to know what you're doing, because For my bachelor thesis, I had a cool project. Yes, yeah, that's it. If you want to see my project, I have it's publicly available. GitHub.com Nagels, I think. Streaming, beautiful. You can see my VHDL code, I guess. Yes, this is the project. So this is the VHDL part. These are all the VHDL files for the CPU. That's called the SCART32, and an application, an C application, a bootloader application that is capable of I think this is only the first stage bootloader. It was quite a lot of work. But this was a cool project, and as you said, Mr. Elfman, really, you made a CPU. This is a big project. Designed, yes. And yes, I have used the CPU because it is so much to do, not only because of the VHDL, but you also have to make a toolchain. I guess you don't have designed your own toolchain, did you? I guess. You have made a compiler too? No, you have made a C compiler. Are you kidding me? Yes, sure. Post the link. If you have created a VHDL CPU and so this is okay. CPU VLDR. The second tab is the C compiler. No way. Boah. No. What kind of thesis was this? This a master or a doctor thesis? What? How long did you work? No, bachelor. This is a bachelor. Oh, come on. Then I thought I was crazy, but come on. This is hardcore. How can I run? Here. Connected to my home connection. This is no way. Is this if I run this thing, is this working on your machine at your home? Yes, it goes to a Raspberry Pi, which then programs and executes the code on it, then reads, etc. Oh my god. This was my first project. I've made a connection board from the Raspberry Pi to the DINO DEO Nano. Do you know this board? DEO Nano. Yes, the idea was to make a platform to make signal processing like an Arduino for signal processing. This was the first idea. And yes, it's the Altera one, and it's quite cool because it's a cool board with a low cost. In the low cost, yes, that's super old. Yes, unfortunately, my last project. Oh, what did I close? The last project is long time ago. It's still too expensive considering its age. Yes. I must confess that I'm quite far away from the FPGA stuff. It's so cool. I can. Do you know Gyroskaya? Gyroskaya. If you're into FPGA programming and all the hardcore stuff, if you're into hardcore stuff, then you have to see Gyroskaya. He's coding a lot of FPGA stuff. And kernel driver and everything. So check his channel out. It's quite cool. Yes, amazing project, Mr. Elfman. This is completely hardcore. You want to run Unix? Okay, you're completely crazy. No, just joking. It's a long way to get to this point. You even have made a cool, very cool looking page and a lot of instructions supporting. What's that? Tick places the number of clock since execution began in register. Interesting. A time function at instruction level. That's useful, I think. Okay. I'm looking at this instruction into float. That's interesting. At which faculty of engineering? Where are you from? That's a cool project. Audience hints. The list is a bit outdated. The compiler uses some compiler-centric interactions. Okay. How long did this take you? Let's just append this at the top. Oh no, stop. Mr. Elfman. Lots of hair was pulled. Yeah, it's a 3-month project. Yeah, my project was done in 3 months also, but I used a a CPU with an existing GCC toolchain, because I wanted to use GCC, and it was quite it was finished, but the project had to be single pass and optimization. Yes, of course, you can't do everything, but I know what you have done. So it's I had to change the CPU so it fits for my situation. There was a Hello World project, and the CPU was using the internal memory, and I had to implement an SDRAM controller and to connect to the external SDRAM controller. And this is a point where things get hairy. As you said, this is where the timings get hairy, because as long as you are in the FPGA, the how is it called? The timing stage. The synthesis is done in multiple stages. And at first, the last step is the placement. The synthesis step. You first, I think there is the placement, and then you have the timing check. I don't know. I have forgotten everything. Not in the CPU, but the synthesis process. If you create a FPGA project, then it has multiple stages, and if your code is in the FPGA accessing the resources in the FPGA, then the synthesis tool can check the timing constraints. You are setting the clock time, and yes, if you can set the clock time, and the synthesis tool is checking all the stuff inside the FPGA. But if you have an external RAM, for example, then you have to manually to do cause of timing constraints. Yes, but it's even harder if you have an external component. Then the synthesis tool can't help you. Then the synthesis tool can only tell you the setup and hold times, the delays of the endpoints to the FPGA. And I can remember I wanted to increase the clock frequency, and I had to then I had a very strange case, because if you're communicating with a RAM device, then you have to select the columns and the rows and stuff, and because I was too fast, I had to add a whole pipeline stage to the CPU. It was so crazy, because the RAM was not fast enough. It was fast enough, but then you had to wait one more clock cycle, and I had to buffer the instructions I have fetched. This was completely crazy, but it worked. It worked. I did not have a star at. It worked like that. I had an instruction at every clock cycle. This was fine. I had a clock cycle, an instruction for every clock cycle. This was very important for me. I didn't want to have a high frequency, but not filling the pipeline. I wanted to have an instruction at every clock cycle. I only had a stall if I had to refresh the contents of the SD RAM, because it's a dynamic RAM. I had to, you're fetching all the stuff, and then you have to refresh the RAM, and then you have to stall the CPU. But in normal operation, most of the time I was able to fetch an instruction at every clock cycle. So it was quite performant at the end, but this was the end of the project. I was satisfied because I had to, I think the document is still in there. Documentation. Oh, it's single cycle. Yes. Yes. 3 months is not that much time. You must have been very quick to create all the stuff in 3 months. And this was the booting, the memory layout, and this was the communication, I think, to the let's see. Wait, I think I have an updated version. No, I don't think so. But you had to, you can get from the protocol you have to get some information, and from the datasheet of the DRAM, then you can visualize the structure of these windows, and then you can check this. Well, single cycle except for the floating point operations did some tricks to go to multi-cycle. Yes, wow. This is so much work. Cool, you made this. I have to check out your project someday. How is it called? How is your CPU called? C15 metal? Is this the name of the project? C15 metal? Cool. That's a very cool project. Where are you from? Oh, Canada. Don't call me sir, just call me Joe. You are the sir if you're creating a whole CPU. Come on, that's completely hardcore. Let's check if you have multiple tabs open. Nice, cool. Fancy, that's hardcore. In 3 months. Respect, sir. Try out the sample quicksort. Where is the sample quicksort? Try out these sample C files. Just click on the hyperlink and download. Oh, you have multiple. Oh, come on. You have multiple. Holy. No, stop. Okay. I think yes, I know. Ooh, quicksort. Running. Okay. Oh, this is stable and fine. This is interesting. You have a C code, but what is this? What is this? Oh, compiler intrinsics. Makes sense. Yes. Oh yes. Because of the whole poor. It's not pure C, some fun stuff added, like length to erase. How is the ABI working? The ABI application binary interface. How is the stack working? Do you have? Oh yes. Yes. Is if I call a function, is the stack and the stuff working? Is it working automatically? If I remove this thing, there is no recursion stuff. This has limited stack space. Yes, but you have a stack. Interesting. Cool. Memory region. Okay, this is the result. But only return address is pushed, no stack frames. Yes, this is what I meant. Yes, because this is return address makes sense because it's the bare minimum and for the whole thing, and the rest is done with these intrinsics. Because the stack frame stuff is, it's so low level and it's a lot of work, but it's amazing. It's really amazing. Respect. Yes, that does make sense too, because this would make a lot stuff harder. In fact, I have programmed. I have to tell you something. Just 3 data types: uint, int, and float. Yeah, that makes sense because it makes a lot of stuff simpler. I have worked on a machine someday where I had a character, a short, and an int, and a long, and a float, and all of these things had a size, a byte size in the memory. Memory byte size was 6 bytes. Every single it was a digital signal processor, but they're kind of half not allowed to copy by value structs. Yes. I had this machine with every type the same size, and if you had it had 6 bytes, and this is fine because the C standard says that the size of long has to be greater or equal to size of integer, and it has to be greater than or equal to size of short, and greater and equal to size of char. This, I think it's defined like that. And the strange thing was that if you made a size of char, then or short or int and long, then you had this return value. And at first I was surprised because I thought this is a bug, because I expected it to be 6 at least. but not 1 in every case. And it turns out that the return value of size of is the number of jar-sized memory units that are required to store the type given. So if you have a short that has 6 bytes in memory, this was so strange because I had a short with 6 bytes in memory and the size of was 1 because it was as big as a character. Very strange definition. But it was cool to implement with on this processor. I had 2 completely different processes, and this was cool because it forced me to make portable code. This was quite a lot of fun. Yeah, you don't have any of the basic C library stuff. I'm completely impressed. Honestly, I'm completely impressed by the sheer amount of function you have implemented in 3 months. It's very cool. Respect, big respect. BCD, what's BCD? Place number BCD. BCD is binary place number. BCD, that's an encoding, I think. Yes, number 2 digits. Random number generator was hard to do in Verilog. Number generator, pseudo number generator, or a random generator, random number generator. I did an oscillator. Calls the urand instruction. Urand. That's an interesting thing. Rand. Can I search? Yes, of course. Why don't I search rand? Yes, rand generates a 32 random number and places the random number into register A. How did you implement this random thing exactly in Verilog? A real random thing, like, because there is a pseudo random generator is something. Pseudo random generator, is it like something like this? An MP-ING oscillator? No, it's not a pure random. It's close enough. Okay. You made this with an oscillator. That's interesting. That's interesting. Okay, yes. Okay, I can imagine this. It's quite hard, but it's still. Crazy. 3 months, come on. This is hardcore. Interesting project, very interesting project. You have a lot of power. This is hardcore. Okay, let's finish our process. we are making a terminal game server. Do you have Telnet, Mr. Elfman? Do you have Telnet? Everybody's got Telnet. That's what I want to hear. Type in your terminal. Let's make a small match. Type in Telnet Nicholas USTO and then for 1000 I think. Let's try it. No. Nope. Why? Yes, Nicholas testing like this. Let's try. Yes. This is what we have implemented so far. And then you have this interface. And then I can create a server that is called Connect4 and you can join to the server. No way you don't have Telnet. Are you on a Linux machine? Are you an Arch user, an Arch Linux user? That's the only thing I can imagine, that you don't have Telnet or you have Windows. Oh, that's interesting. I have been disconnected from the server, from my own server, because yes, I was not okay. Got it. I have not tested. I have not tested your client. This is very interesting. I don't know what kind of clients you have installed. Ooh, you got the IP. Well, your DNS is not resolving. Yes. This should be the IP. So telnet this and 4000, I think. Hopefully your client is working. Something seems to be connected. And oh yes, Flea, nice. And then press 1. If you press 1, then you are in team 1. Yes, perfect. And I'm team 2, and then I press enter. Hopefully. Now we can you can I'm sorry, you can navigate with H and L. H and L. I have to Ah, cool, you're moving. I have to add the arrow keys because it's annoying. I'm a Vim user. That's the reason why I have used these H and L things, but seems. Ooh, I have to be careful. I have to be careful. I should not talk that much. Okay. Oh, ho ho. That's it. I've won. That's cool. It's working. It's quite cool. And as you can see, we have random names. The goal is this is the lobby, and the lobby will be much greater and bigger in the future. Because I want to be able to chat and play against an AI and stuff like that, and having multiple games. You can create multiple games in the future, and all the games should be cool. You do, yeah, that's cool. That's an interesting. I need to add multiplayer to a game I'm working on. Yes, this thing is designed to be multiplayer for every game. I want to be able to play against an AI in a team. So because this is a design of the system, it's quite cool. And you need to add a multiplayer to game. Yes, that's what kind of game? Your thing should be easy peasy to load balance. Yes. At the moment, I have prepared the structure, but at first, I try to keep it low level, kind of, and I want to go step by step. At the moment, I'm still working on the account creation stuff, but this is done. It's almost done. We have created the entire SSH protocol. We can send an email to the user so it can verify the account. The user can verify the account. We have an API that is processing all the requests from the gaming server and then authorizing the stuff. So it's quite, we have done quite a lot, and the user accounting stuff was quite a lot of work. But then, as soon as this is finished, then we are quite happy. And as you can see, you have a settings menu. And if you're using Telnet, then you are a guest. Yes. At first, you should make it accessible from the web using WebSocket. Yes. At the beginning, we will the access will be possible with the default port of Telnet and the default port for SSH. Then you will be able to access with Telnet Nagelus USTO, just this, or SSH and then username at. These are the two channels you can connect to the server at first. And then if somebody is using this thing, then as you can see, we have a cool version history. And these are the libraries we are using. So it's quite advanced at this point already. Quite happy with the outcome. And if you're logged in, and then you can set the gamer name and stuff like that. And that's the scope of the project. It's messing around with the processes. The main goal of the project is to test the structure, the software structure I'm using. Yeah, this is the game I want to add multiplayer. No, come on, Minecraft, cool. Oh, I can move. Ah. Has control of your point. Okay. That makes sense. You made a Minecraft. Nice. Oh, I have to. Oh yes, I have to save changes and then I have to reload this thing. Yes, now it's working fine. I'm using a Vim plugin. Yes, no, fine. I'm using a Vim plugin in the browser now. I have to ignore this website. That's a cool clone. Nice. That's so cool. Holy shit. And in which language did you made this? Is this is this TypeScript? This is C++. Okay, interesting. Compiled to WebAssembly. That sounds interesting. I have never used WebAssembly. Yeah, it's that's a lot of work, the UI and all the stuff. This alone is a lot of work, I think. Look for caves. You have no, come on. You must have created. Is this a static world or is this thing created? Can I swim? Oh, I can swim. It's random, yes. Oh. Random generated. Amazing. Hardcore. That's hardcore. So now I can play Minecraft for free. That's cool. And who needs a menu anyway? So I'm quite satisfied. Ah, what's that? Is this a cave? There is a copyright on the textures. A beefy computer? No? Maybe. Oh, what's that? That's the end of the world. Cool. I'm swimming in lava. Oh, and can I escape? That's cool. Very cool. Ah. Oh, I think I have found a cave and I have floated the cave. But it's cool that this is done in C++ and then it can run on the web. That's very interesting. I've never used this thing. WebAssembly. I've coded some stuff in OpenGL. Is it, do you know that? Is this similar? No. It's OpenGL. Oh, that's cool. Oh, come on, that's cool. I have to check this out. So you made this whole game in OpenGL. My stuff in OpenGL is like drawing a button. Drawing a button and stuff. So this is a lot of work you have done. Cool, 20 FPS on the Samsung. Nice. On the TV, cool. I have to check this open WebGL thing. This is amazing. Cool. Nice. So I think I have lost the connection for it's called EM scripten. What's EM script? Oh, cool. This is interesting. Okay, this is important. Enscripten.org. Thanks for the link. That's very cool. WebAssembly. Once I'm done the game, I will post the source. Cool. I have used for the OpenGL stuff. Thanks for the follow, Elfman. I have used. This was quite. I can remember that this was quite hardcore. I used GL framework. It was called GL framework. That is used. With this, you have the surface, the window itself, in a portable way for Windows and Linux, and you have the input and you can read all the input devices in a portable way, and you are able to print on the surface. This is quite a cool thing. And then I initialized all the OpenGL stuff. And that is creating all the shaders and setting all the stuff. It's interesting at which point I can reuse the code for the WebGL stuff. I have to try this. This is really cool. That's a cool tip. Thank you very much. I want to make this compatible with the WebGL someday. This project is on hold. This project is on hold, unfortunately, because I'm working on this terminal stuff at the moment. Unfortunately, the day only has 24 hours. Should I call this name user? Yes, let's call it name user. If not size, then return empty username, and then we have not the service but your access requested name. Yes, fine. And then password pass user. Oh, come on. Name user, and then we have pass user. And this is pass user, empty user password, and then we have this thing. Name user, name method, name user, that's fine. If mState is equal to this temp state to be in kind of an idle state. I love this structure so much, Elfman. I can't tell you how much I love this structure. It's so cool. ID, no, not ID, that's bad. Name user and name user. Method, name, pass. Method, name, pass. Yes, fine. We are creating this thing. We are not waiting for an authentication to be done. We are not this, remove this and this. I don't want to create the filtering. Yes, and I don't want to. Yes, wait a moment. If 0, I have to make a chunk here. Because we have a secure connection start, then we start the SSH transferring process, starting the connection. Then we are starting something else that is, it must be here. This must be here. Yes, we are not starting the filter, but the user authorization process. At this point, let's create both processes. We do not repel anything. Let's see. We have a secure connection start. We want to create 2 processes. The first one is the secure connection, and the second one is the user authorization process, and we are starting both processes at the same time. Yes. And then we are waiting for the authorization process to be finished. The user authorization process has this output, the username and the authentication ring. That's fine. Looking fine. And then we can repel the user authorization process. That's cool. And we can start the filtering process. Yes, I think. Yeah. I think. Let's see if this thing. If this thing is compiling somehow. No. Expect the constructor. we have to remove this filtering stuff. Filt. The constructor isn't matching because we have changed the constructor. It's initializing the mpcon variable. Oh no, this is the administration server. No match for operator, authentication attempt, method. I just want to, does not have any field. Gamer interacting. Yes. We want to remove this thing. We want to add, we have added this thing. We remove has no member aborted. Why not? Am aborted. I think this is fine. Removing this thing. No match for operator. Yes, because we need to method. We have to convert this thing to a string, as well as here, as well as here. Wrong. Not handled in switch. We do not have this thing. Yes. And the SSH authorization has been removed. We have a secure connection start, and then we have a user authorization done wait. This is fine. Oh, almost. A user authorizing not declared. That's true because we have an state temp. This is declared. We have start, initialized, state, start, then second state is this one. Then we have an authorization attempt wait. We don't have to jump to this temporary thing. That's fine. It should not execute multiple things because we are checking the queue. And this is compiling again. Nice. Also, we have made a big restructuring, and let's see what's happening now. Yes, that's fine. And now, okay, this is almost working. As soon as I have finished this, then we have to rate because it's 1 o'clock. That's so, oh, that's so bad. I have to go to bed. SSH authentication access requested. I want to remove this message if 0 and if next step is to make a test and then Received data lang. Received authentication request. Authentication. Fine. Access user authorizing. Let's check the. This is the new process tree structure. Gamer interacting has started an SSH transferring, and now the SSH authenticating is not a child of gamer interacting, but of user authorizing. Both processes are waiting for an authentication attempt. And we have received the password here. Let's see why this is not. Yes, I think I know. What? Oh, no. This is the last thing I will do. Because two hex a string, I think it should be 2 hex string. I have I have to go to the toilet one moment. So, last stuff for today. We have a password user, and that's the hash, password hash. Fine. From the password hash, we have to create a string. String hash, and this is const char pointer. That's not the best thing. We can optimize this later. Data. The reason why we have strange signs in the log is because we have the hash in binary form. We have the password. We have fetched the password from the password we get the hash in a secure byte block. And then we have to convert this to a string because we want to make this to a hex string, I think. And that should be the last thing we do for today. Pass user, is this a pen? Nope. This is the string hash, yes, and the this is pass user is equal to hex string, and that is string hash, I think. We have the password, we make the hash in a secure byte block. Then we make a hash string, and then we can return the string. Hopefully. It's compiling at least. Oh, that's so amazing. Okay, perfect. So now for today I'm done. We have done a lot of stuff today. We have verified, we have added another SSH packet, so we can register a supported signature algorithm for the public key, because we needed this to verify the behavior of the clients, the various clients. And we verified that if we decline, thanks for the follow, Mighty House. Unfortunately, we are quite at the end of the stream, but next time I think we have done the whole. We have verified the behavior of the various clients, the OpenSSH client. The OpenSSH client, the SCP and the PuTTY, we have seen the different behavior for the various authentication methods over SSH, and we even have restructured the process. We have changed the process because the first structure of the processes, of the authorization processes, was it was a first version, a tryout, but now we have, I think, the final structure of the SSH authenticating process and almost the final structure of the gamer interacting process. That means we have a secure connection, we are creating an SSH transferring process and a user authorization process, and then we are waiting for the user authorization process to be done, to be finished. If it's finished, as long as this thing is not finished, break and return pending. If it's not positive, then we could not authorize the gamer. if we were able to authorize the gamer and we have a gamer name and an authorization ring, then we repel this client, this child process, and remove it. And then we are creating the SSH filtering process that's a process which is opening the channel, the SSH data channel. That's the data part of the SSH protocol architecture, and it's opening the channel, the data channel, and it's making the base filtering stuff. And then we can go to the selection. The only thing we have to add in the gamer interacting process is a special situation if the user is registered but the account is not activated. Then we have to present the user with a page. This has to be done in the gamer interacting process, but this can be done next time. The user authorization process now is almost finished as well. Yes. Oh. Yes, that's for next time. That's for Tuesday. We will implement the user authorization process. That is, this process will include the creation of an user account and the password setting interface. So I think next time hopefully we will be able to start the whole widgets stuff we intended to do today, but fine for me. Okay, authentication, yeah, that's what did we change? Oh, we did change a lot of stuff. We had an invalid signature error that we have to check. I think this is because the numbers have to be a signed number. The multiple precision integers have to be a signed number, and I think I have violated an RFC, so this is fine. Move downloads RFC to not on doc SSH dot and the best commit message of all is save because I have to go to sleep. The last thing we will do is raid somebody. WebAssembly, I can... Elfman, oh come on, very motivated guy. So I can remove this, and this is something for me, that's this. Or we can we can make literature. Telegram. key generator generation. Download. Whatever. So that's fine. Everything is closed. Oh, come on. Minecraft. I think it's written, yes, Minecraft. Like that. Cool. So see you next time. And Twitch, who is still online? Not many. This is the Accelerate guy. They are applying to jobs. What kind of... he's coding in Rust. I do not... You know what? Today I will not raid anyone because I want to stay. If I'm raiding somebody, I want to stay for a while. So see you next time.